We're going to consider now two reactions that are actually parallel. They are competing. And let's see, we're going to be talking about thermodynamic product and kinetic product. So let's draw one profile for those reactions. Let's say that we have the following reaction coordinates. So reactants are the same. We say these are competing two reactions that happen at the same time. And say that we have here A plus B. And now I'm going to draw one curve like that. And this is C plus D. And it's starting from the same point. I'm going to have another reaction like that. So start here, but I have now products EF. And say that I have a question asking me what is the thermodynamic product and what is the kinetic product. I'm going to use another color. In a question like that, deciding what is a thermodynamic product is finding out which of these is more stable. So now when we look at the reaction here that leads to the formation of CD, that is energy, free energy here of C, and that's AB. Notice that they are below, so lower in energy than this. That's where my scale is. So they're lower, so CD are more stable. Actually, it is interesting that if you see the profile of the reaction leading to CD, this is CD, this reaction here. Look at the profile, CD. This reaction is exergonic. Whereas the reaction AB, you go up here, and EF, now this reaction is endergonic. Right there, that says a reaction that is exergonic is product favor, whereas a reaction that is endergonic is reactant favor. So right there, the one that is product favor is this one, so that's your thermodynamic product. So my answer to the first question, what is a thermodynamic product? This is CD. They are lower in energy. This reaction is exergonic. Now, that was G. I erased it because it didn't have room. Okay. Now, if second question is about what is the kinetic product? So here we're going to see what products form faster. What products form faster? Here. For that, to answer that, we're going to be looking at the energy of activation. So if we look at the formation of CD, then the energy of activation is this. Right? Now, looking at the other reaction, well, we start here as well, but now the energy of activation is all of that. So notice that the energy of activation also for the reaction here that leads to the formation of EF has a larger energy of activation. So this reaction is lower. This reaction leading to the formation of CD is faster. So in this case, the kinetic product is also CD. That's the one that forms faster. Again, it has a lower energy of activation. Notice that for this case, the kinetic and the thermodynamic products are the same. But we can have a different scenario. So I'm going to do another plot. Let's see. I'm going to draw it elsewhere. Let's see. To that one side. Now I'm going to say one like that. I'm going to have the two curves cross. So this is going to be EF. This is AB. And CD are here. Now, actually, in my drawing, it looks like the profile of the reaction AB given E and F is approx the same area. So I'm going to change that a little bit so that I have the two reactions being exergonic. So I'm going to start here and that in the same place. Now I have that, it's a bit lower. Just lower even more to make it clearer. All right, so hopefully that's better. And so, again, if the question is, what is the thermodynamic and the kinetic product? So what you want to do here is find out what is more stable. So when you see the differences in energy, again, you're starting at the same point. Then the two reactions compete, but C and D are more stable, so C and D are the thermodynamic product. But when you look at what is the kinetic product here, notice that we're going to be comparing, as we did before, the energies of activation. So the energy of activation for this reaction leading to the formation of EF is this much. And we notice that the energy of activation to form C and D is actually larger. So this reaction leading to C and D is slower. So the kinetic product here is E and F. In other words, this product formed faster. Kinetic. So again, notice that this is a kinetic product, and they don't need to be the same. What we need to do when we have a profile like that is analyze the difference in energy. Again, when you're looking at what product is favored thermodynamically, you want to look at the difference in energy in the products here. And that was the case here in the two scenarios here have thermodynamic product being CD here as well. But when we talk about kinetic product, is the one that forms faster. So you're looking at which reaction has a lower energy of activation. In this case, it was also CD, that's a smaller energy of activation. And when we're looking at this profile, actually, it was smaller, the energy of activation to form EF. So that was faster. That's your kinetic product.